Okay guys, this lesson is going to cover actually section 2.5 in our textbook, direct relationships, and then or variations, and then 8.1 is indirect and joint variation or relationships. Okay, so we want to be able to write a direct variation, we want to be able to write an inverse and a joint variation, and we want to be able to, differentiate all three. So we're going to start with our first example here right at the gate. The only way you can really tell variation is if you have y by itself. So in order to rewrite an equation so that we make sure that it shows variation, we would have to do that. So in this one, we're going to multiply both sides by 5. We end up with y equals 5x. And then for this equation here, if this was just y equals x, we'd have a solid variation here. But we don't. We have y equals x plus 2. And y is by itself already. So it can't be considered direct because of this plus 2, because of the constant changing it. Okay, so for y equals x plus 2, we would call that a neither. And then for this guy we would divide by x, canceling x there, and divide by x, we end up with y equals 4 over x. Okay, so now we can talk about different variations. So our first variation there, a at the top, is going to be considered direct. And the largest reason for that is as x gets bigger, y gets bigger. Whereas in C below, we would call that inverse. Because the x is in the denominator here, we would say that when x gets bigger, y gets smaller. So if they're growing in opposite directions, then they're considered inverse. And I know the middle one kind of looks like direct because as x gets bigger, so does y. But as x gets bigger, y gets bigger plus 2. So it's not technically direct because they're not growing at the same rate. Okay? And so we can't consider it direct or inverse. It would just be a neither. Alright? So we want to be able to write inverse and direct variations. So this example asks us to do it inversely, but I'm going to also do one directly. So we'll start with direct. So direct is always of the form y equals some constant that we'll call kx. Whereas inverse is going to use the constant, but it's going to be over x. Y equals k over x. Okay? So they're telling us that y equals 8 and x equals 3. Okay? And we want to write an equation that relates x and y. And then our next goal is to find y when x equals -4. So the first thing we do is we plug in our knowns. We know that y equals 8 and that x equals 3. But we don't know our constant k. We don't know the constant rate at which this thing is going to grow. Okay? So in order to solve for k, I'm going to divide this by 3, divide by 3. So then I can write an equation of y equals 8/3 x. Okay? Or you could say 8x over 3 if that helps make a little more sense. So that would be direct. If you plug in, say, 2 for x, well, then y gets 8/3 times 2 bigger. And it's going to be a direct variation. As x gets bigger, y will get bigger. And k is kind of the rate, or slope, if you will, of the line. Whereas with inverse, we end up with a different scenario. We would say, alright, well, 8 equals k over 3. And in order to solve for k, we just multiply both sides by 3, and y then equals 24x, because k equaled 24. 24 over x. because k equaled 24. So all you do is you really take this guy and you plug it back in for k right there, and you write the general form. So then I know that, let's say I get, I don't know, x equals 10. Well, then y equals 2.4. If x equals, we'll write that, if equals 2.4. But if you tried, I don't know, 100, 24 over 100 makes it 0.24, which is a lot smaller than 2.4. So you can see as x gets bigger and bigger, then y gets smaller and smaller. Alright, so y equals 24 over x is our inverse relation. Okay, so here we have an experiment that was done in the biology world. The table compares the wing flapping rate, R, right here, in beats per second, to the length, wing, in centimeters for several birds. Well, the question is this inverse, direct, neither? What is it? Okay, so then we want to write the model for the relationship between R and L. So we need to look at some things. First, we want to know what's our domain. You know, what are we plugging in? What's x, really? And the question then you ask yourself is, well, what was measured? Because measuring things, you measure outcomes based on data that you know. Or, excuse me, what do you observe, really? The observation was beats per second. And observation is going to be your output. That's what came out of the experiment, if you will. Whereas your input are all the things that you looked at when you set up the equation. You know, you picked a carrion crow, you picked a common scoter, you picked a grebe, you picked a curlew, and then a black-backed gull. Okay, you picked those things and you said, all right, well, you know, I can right now tell you that here are their wing spans, and what I want to know is, how does their wingspan affect their beats? Well, if I'm asking how does the wingspan affect it, that's what I'm putting into the relation. So that's going to be my x values. Whereas the beats per second is my outcome, or my y values. So domain or range. Domain in x's, and range in my y values. Okay? So then we want to look. We've got 32.5 centimeters starting here, and we're getting 3.6. And then the wing gets a little bigger, or excuse me, shorter, and the beats get a little larger. Shorter wing still, faster beats. Longer wings, a little slower beats. Longest wing still, slowest beats per second. So it appears that as x gets bigger, y gets smaller. So I would say that this is definitely an inverse relationship. And we can, you know, get to work then. Y equals k over x. So let's try 2.8 equals k over 42.2. I used our last guy. Okay. So then we're going to multiply by 42.2 to get k by itself, and you end up with y equal to 118.2 over x, because k equaled 118.2. And now you have a way to say, alright, well, if I know the wingspan of a bird, I can give a pretty solid model or guesstimate for what the beats per second are going to be. If you wanted to be more accurate, you would obviously need to do several more birds, because, you know, 5 birds is not a very high statistical analysis there. You would want more data points than that for sure. Over. Okay. We want to write some relationships here. We know the first two. Y equals kx is direct. As x gets bigger, y gets bigger. Then our other one, inverse, k over x. As x gets bigger, y gets smaller. Then z is gonna vary jointly. We're adding in a third variable because it works with both x and y. And then the last couple here, we get y is inverse with the square of x, or x squared. And then z, it varies directly with y, so ky, and inversely with x, over x. Okay? So we're just kind of breaking it apart here. We said, direct with x, kx. Inverse with x, k over x. Jointly with x and y, kxy. Inversely with the square of x, k is still over because it's inverse the square of x. And then we've got direct with y, so k times y, and inverse with x, so x goes in the denominator. Alright, hope that helped. Give the homework a try, and we'll see how we did on day 1.